Lasya, am I audible? Am I audible?
Yes, sir.
Okay. Lasya and Srivarshini. We
Yes,
had
sir.
completed. Yes. Anyone saying anything?
No, sir.
So basically, in the previous class, we had completed rate of reaction, rate of appearance and disappearance, rate law expression, and order of reaction. Last year, have you studied this chapter, chemical kinetics, and Srivarshini?
Yes, sir.
Yes, sir.
Okay, so I am going to start a new topic here, that is molecularity of reaction, or we simply say molecularity. So basically, what is molecularity? So how many reactant interacting, or how many species interacting with each other, that is called molecularity. So first I'm going to write the definition, and then again I will explain. Total number of molecules, either molecules or either atoms or ions, or we can write reacting species. That means we are talking about reactant. Reacting species participating in a reaction. Participating in an elementary reaction. Elementary reaction. I will explain what this elementary reaction means. Is called molecularity of reaction. Molecularity of reaction. So basically, there are two types of reaction. One is elementary, and another is complex reaction, and we also call it sequential reaction. So basically, this sequential or complex reaction is in more than one step. More than one step, basically, there will be 2 or 3 reactions to get a product. And elementary reaction is the reaction which is in a single step, single reaction, and you will get a required or specified product. That is elementary reaction. Now come to the point, what is molecularity? So basically, when a reactant is reacting, so basically we see how many or total number of molecules or atoms or either ions, atoms, or anything that is reacting or participating in a chemical reaction, and chemical reaction must be elementary. Chemical reaction must be elementary. That is called molecularity of reaction. Just I'm going to take an example. First, I'm going to write some point about it. It is theoretical concept or quantity. There is no practical evidence. Theoretical quantity. It is theoretical quantity. Next, we can write it can be an integer. It cannot be 0. It can be an integer 1, 2, or 3. In our syllabus, we will only deal with unimolecular, that means only one reacting species, and bimolecular, that means two reacting species. And we will not talk about this termolecularity, that means three reacting species. but it cannot be zero or fraction. As you have seen that the order of reaction can be fraction, zero, positive, negative, but molecularity cannot be negative, fraction or zero, but order can be. Next point. In an elementary reaction, molecularity of a reaction is equal to order of reaction. You know what? You can have order of reaction of each state, but and also you can have an overall order of reaction, but you cannot have overall order of molecularity. There is no meaning of molecularity for a complex reaction, but you can get a molecularity of elementary reaction, whereas order of reaction can be defined for elementary reaction as well as complex reaction. Is that clear? Lasya, Srivashini, Prim, and Madhya.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you. Please do write it. Let me know when you are done with this. Are you done with this? Madhya, Prim, Lasya, Srivastava.
Almost, sir.
Okay.
Students, sir.
Please take your time.
Done, sir.
Very good. One more point I am going to write it. Complex reaction. Each stage of mechanism is defined separately. You can define it, but if you want to get a total molecularity, So total molecularity of a complex reaction is meaningless. That I already explained. Please do that.
Done, sir.
Very good. So this was about molecularity. Now there is another topic, that is pseudo first order reaction. What is this pseudo first order reaction? So first I'm going to write it and then I will explain. Please do write. A chemical reaction in which value of order of reaction is 1. A reaction which has order 1 but molecularity is greater than 1, but molecularity is greater than 1 is known as pseudo first order reaction. I'll explain it with the help of an example. It's very easy to understand what is pseudo first order reaction. So a reaction in which order of the reaction is 1 but the molecularity is greater than 1, that means it will be 2 or 3. That type of reaction is basically our pseudo first order reaction. For example, I am going to take this ester CH3COO C2H5. Hydrolysis of ester in the presence of acid will give you CH3COOH plus C2H5OH. Now see, you have seen this reaction in class 10, that is known as saponification. In organic chemistry, carbon and its compound, there was a term esterification. That means basically when you are going to react carboxylic acid with this basically ethanoic acid with ethanol, then you will get an ester. And if you are going to reverse it, that means basically this ester will be hydrolyzed reaction with water in the presence of acid, then you will get back your reactant, that is carboxylic acid, ethanoic acid and ethanol. So this was the organic reaction. Now if you are going to write the rate of reaction, rate law expression, there will be K, and rate law expression is expressed in terms of reactant. And experimentally it was found that CH3COO C2H5 N2 H2. Now as you know that basically this H2O is in excess. This H2O is in excess. So H2O I am going to take, since it is in excess, so I am going to take H2O as constant. It will be constant because it is in a very large amount. Like if you have, we can consider water, that we should not. We can consider water as constant because it is not what we say. What we will, wait a minute, I am going to take another example. If you are going to take 1 quintal of sugar, will you be able to complete this or eat this 1 quintal sugar in 1 month or 1 year? 1 quintal sugar directly. Can you eat it? Rim,
No.
please do respond. You cannot eat it in 1 month or 1 day. So basically, if you are going to use this 1 quintal sugar, it won't be ending so easily or so soon. So we can take sugar as constant because it's not completed or it's not uh, yes, it's not what we will call it. Okay, let's say then since H2 is in excess, it will be constant. So I'm going to take K into H2. Since K is constant and H2 is also constant, so I'm going to take another constant K dash. Now the rate law expression will look like K dash into CS3 C double O C2H5. Now, if you are going to look at this rate law expression and tell me what will be the order of the reaction, I want this answer from the two new students, Lashia and Srivarshini. What will be the order of the reaction from this rate law expression? What do you think? If you know order of the reaction,
Sir, is it
Lashia, you are
one?
not audible. What you said?
Sir, is it one?
Yes, whatever is the power of the concentration of reactant, that will be the order of reaction. Now you can see order of the reaction is 1. Now, can you tell me how many molecules are interacting with each other? Srivarshini, how many molecules are interacting with each other? 1 molecule of water and 1 molecule of this ester. So the molecularity is basically 2. This type of reaction is known as pseudo first order reaction.
Yes, sir.
So basically we just started pseudo first reactions, pseudo first order reaction. So basically this value of order of reaction is 1, but molecularity is greater than 1. This type of reaction is known as pseudo first order reaction. Please do write it and let me know when you are done with this. There is another topic that we had already discussed. I will just show you. Everyone done with this? Rim,
Yes, sir, done.
very good work.
Done, sir.
Lashia, Madhya,
Yes, sir.
Ayman.
Yes, sir.
So Ayman, just look at this. We started from here. molecularity of reaction. Just take a screenshot. Basically, molecularity of reaction is how many reacting species, how many reacting atoms, molecules, or ions it is. That is molecularity of reaction. And molecularity of reaction is defined only for elementary reaction. What is the difference between elementary and complex reaction? Complex reaction is basically in more than one step, and elementary reaction finishes in one step. So there are some characteristics of molecularity. It is a theoretical quantity. It can be an integer 1, 2, 3, but it cannot be zero or fraction like order of reaction. Also, in an elementary reaction, the molecularity is equal to the order of reaction. Have you taken this screenshot?
Yes, sir.
Also, in a complex reaction, each step will have their mechanism. But if you are going to talk about order of reaction can be defined for one step and overall order of the reaction. But this molecularity cannot be defined. There is no meaning for overall overall molecularity of a reaction. That is complex reaction. So this was basically very basic from chemical kinetics. We started from rate, then goes to rate of formation, rate of appearance, rate of disappearance, then come to the rate of reaction in terms of stoichiometric coefficient, then rate law expression, after that order of reaction, and then molecularity, and then this pseudo first order reaction. Now we are going to start a new topic that will be involving some maths, which is very easy, and that the topic is basically integrated rate equation. Integrated rate equation. So we will study about this integrated rate equation for zero order and first order only. So I'm going to take the first topic as zero order reaction. Do you know what is zero order reaction? It's very easy. See, if there is rate law expression like R rate is equal to K into whatever is the power that determine the order of reaction. If it is zero, I'm going to write R here. If it is zero, that means zero order reaction. If it is one, that means one first order reaction. If it is 1.5, that means 1.5 order. If it is written 10, power is 10, that means 10th order. So I'm just going to define in that term. So it means that the rate of reaction is proportional. The rate of reaction is proportional to zero power of concentration of reactants. Zero power concentration of reactant. Just take an example. If R is the reactant and P is R is converting into P. And if I'm going to write the rate of reaction, I can write rate will be equal to minus D of R upon dt. Srivarshini, are you aware of this? If you are not aware of this, see what is rate? Rate is basically change in concentration upon change in time taken, and this concentration can be of reactant or product. Now since we are studying rate law expression or order of reaction, we will only deal with reactant, because this rate law expression is in terms of reactant. So I can write this, wait a minute, I can again write this rate will be equal to minus D of R upon D. And also in terms of rate law expression, I can write K into R raised to the power 0, and this 0 determines that it is first order reaction. Now you can see from equation 1 and equation 2 of shit. Wait a minute, please. How can I see? Am I visible?
No, sir.
Not at all, right? But my voice is clear, crystal clear, right?
Yeah.
Okay, then let's go. There is power cut off in my area. Now see, since you can see both are the formula of rate, so can I write d of r upon dt? That will be equal to k into r raised to the power 0. Can I write this?
Yes, sir.
Now I'm just going to solve it. Just write it up to this. It's very easy. Very, very easy. Let me know when you are done with this.
Done, sir.
Everyone done with this? Now I'm just going to solve this. Nothing more than that. So can I write d of r will be equal? You know that anything which has power 0 will be equal to 1. If you are going to put power a 0, that will be 1. 10 raised to the power 0, that will be 1. 1000 10,000 raised to the power 0, that will be 1. Are you aware of this? So this will be 0, 1 and k into dt. Can I write this? And can I write this?
Yes, sir.
Now you can see negative on the left hand side. So I just move this negative to the right hand side. And then integrating both sides. Integrating both sides. D of r, that will be equal to minus k constant. So I'm taking it out of the integration sign. Can anyone tell me what is the integration of dt? Ayman, Lasya, Madiha, Rim.
T.
Can anyone tell me what is the integration of dt? It will be basically minus k was there. It will be t, and there is plus I, and dr will have an integration, and this I is constant of integration. This I is constant of integration. So this is an equation that we got right now. Please write up to this.
Sir, the I is the arbitrary constant.
Yeah. It is the integration of constant. Same. Done up to this. Aman, Madiha.
Yes, sir.
Rim. Now see, I'm going to take at t equals to 0. Just suppose the concentration of reactant is R naught. So I am going to put the value of t 0. Then the concentration of reactant will be R naught. Can I write this? At t equals to 0, that means the reaction is about to start or does not start. Is that clear? Now, after solving this, you can see the value of I is R naught. So I'm going to put the value of I in the first equation. Then you will get a formula. R is equal to minus KT plus R naught. And then KT will be equal to R naught minus R. And then a final formula that will be equal to, basically K will be equal to initial concentration. R naught is the initial concentration. This is initial concentration. Initial concentration minus final concentration divided by time taken. Can I write this? So this is the formula of R for zero order reaction. Please do write it. Let me know when you are done with this.
Done, sir.
Rim, are you done with this? Aman? Madiha?
So done.
Done,
Oh.
sir.
So basically, this is the formula of rate constant. R is basically rate constant for zero order reaction. Now, if you want to plot a graph between time and here it is concentration, what will be the graph? See, what is on y-axis? I'm going to take this equation. You know that R will be equal to minus KT plus R naught. As you know that this is on y-axis, so I'm going to put y at the place of R. And this T, you can see, is on x-axis, that is directly proportional, but this is negative sign. Y is directly proportional, that denotes the graph will be a straight line. Since it is negative, so the graph will be downward like this. And this is the point of the concentration, initial concentration. So this is the graph for zero order reaction between concentration and concentration of reactant and time. Please do write it, the graph, and let me know when you are done with this. Very easy. Are you done with this?
Sir, done.
Done, everyone?
Done, sir.
Vashni, Maria,
Done, sir.
Rim. Now see, now we are going for first order reaction. So first order reaction we just did for zero order reaction, right? Now the next point is for first order reaction. See, first order reaction, this is the reactant that is converting into product. If I'm going to write a rate, that will be equal to minus d of r upon dt, and that will be equal to basically k into r raised to the power 1. I just solved it in a single sentence or in a single line. You know that rate will be equal to minus d of r upon dt, and also rate will be equal to k into r raised to the power 1. That denotes its first order reaction. So I just need to solve this. So I'm going to write this d of r, and that will be equal to k dt, and I move the negative side. Now integrating both sides. Integrating both sides. So if you are going to integrate both sides, that will be d of r, and here it is 1 by r, that will be equal to I'm going to k constant out of the sign of this integration and dt. Can anyone tell me what is the integration of 1 by x dx?
Log root x. Yes.
ln x, right? Not log x, that will be 2.303 log x. Is that clear? Is that clear, everyone? So after integrating this, we will get ln r, that will be equal to minus k. What is the integration of dt? That is t plus I integration const. Please write up to this. And mark it as equation number 1. Let me know when you are done with this. Everyone done with this?
Sir, done.
Very good.
Done, sir.
Very good. Now see again the same process. At t equals to 0, the reactant concentration of reactant is R naught. So I am going to apply in this formula. So if I'm going to put the value of t 0, then you know R will be changed to R naught. Now you can see the value of I will be ln R. Now I am going to put this formula, putting the value of I in equation 1. In equation 1, you know it will be ln R, and this is equal to minus k into t plus the value of I is ln R. And again kt will be equal to ln R naught minus ln R. Do you know the basic mathematics of logarithm? That is basically if you have given log a minus log ln a minus ln b, that can be written as log a upon b or ln a upon b. So can I write kt will be equal to ln R naught upon R. And again, if you are going to find the value of k for first order relation, 1 by t ln R naught upon R. And if you are going to convert this ln into log, then there will be multiplication of 2.303. So it will be 2.303 upon t log to the base 10, and there will be R naught upon R. This is the first formula for first order reaction to calculate the value of K, that is rate constant. Let me know when you are done with this. Are you done with this?
Yes, sir.
Done, sir.
Very good. Now I'm going to take this and plot a graph. In this first order reaction, we take first t equals to 0 and derive the formula at initial concentration and final concentration. After this, we will take R1, T1, T2, R1, also that we will deal later. Because first, I'm going to write this equation ln R, that will be equal to minus kt plus ln R naught. Before solving the graph for this, can anyone tell me what is the slope of this graph? Can anyone tell me the slope of this graph? What will be the value? You know that y is equal to mx plus c. And what is the slope? This m. M represents the slope. So you can see t is on x-axis. So this k is basically slope, and slope will be equal to minus k. Is that clear, everyone? Is that clear?
Yes, sir.
Now moving to that graph that we are going to plot. The graph is again between same concentration, that means reactant, versus time t. Now this you can see here. This is LNR basically. So basically this is on y-axis and this is on x-axis, and you can see this is in negative. So since it is negative, the graph will be in downward direction, and this is ln r0. You can see that this is very important to note that this ln r0, you have seen that y is equal to mx plus c, and this c is intercept. This c is intercept. So this is the value of intercept ln r. Also, can anyone comment on the slope? What is the value of slope here? What will be the value of slope? What will be the value of slope here? I told you the multiplied quantity in x is slope. So this is x and this. So the slope will be minus. Is that clear, everyone?
Yes, sir.
Please do plot it and let me know. Let me know when you are done with this.
Done, sir.
Now see, I just did for t equals to 0 to final. Now again taking the same ln r, same equation, kt plus ln r. Now this is for t1 to t2. So at time equals to t1, let's say the concentration is R1, and that's why it becomes ln R1 is equal to minus KT1, and this is the initial concentration as it is. And again, at time T2, the concentration has a concentration of reactant is R2. So we will get ln R2, that will be equal to minus K. What will be the time? KT2, and plus ln R1. Now you can see this is the second equation and this is the third equation. Now what we are gonna do? We are gonna subtract this 2 minus 3. So first write it, then I will subtract it and then derive it in front of it, which is very easy. Let me know when you are done with this. Everyone done with this?
Just a minute, sir.
Lasya, Madiha, and Aman.
Yes, sir.
Yes, sir.
Now see,
Yes,
I'm just going to solve this. It's very easy. So if you are going to subtract 2 minus 3, so left will be subtracted in left and right will be subtracted in right. So this is KT1 plus ln R0. And what was on the third equation? Negative, since we are subtracting. So negative will be positive and positive negative will be negative. Are you getting my point, or should I explain more? 2 minus 3. So if you are going to, this is the second equation on the right hand side, and this is the third equation on the right hand side. Since we are subtracting, so there will be negative sign that will make it positive, and this will make it negative. So this will be cancelled, and again we can write, since log a minus log b, that is ln R1 upon R2, that will be equal to, you can see this is positive, so I am going to write it KT2 minus KT1. Can I take K common, and it will be T2 minus T1. That will be equal to ln R1 upon R2. Again, if I am going to calculate the value of K, it will be 1 upon T2 minus T1 ln R1 upon R2. So this is the formula in terms of ln. If I want to change it in log, it can be easily changed. There will be multiplication of 2.303 upon T2 final time minus initial time, and then log to the base 10, and there will be R1 upon R2. This is the final formula. Please do write. Everyone done with this?
Yes, sir, done.
Madiha, Aman,
Sir, done.
Yes, sir, done.
so can anyone plot a graph between ln R1 upon R2 versus time?
Sir, is it a straight line?
On which side? Downward, upward?
Sir, upward.
Will it be like this or passing from origin? So it's very easy to decide. It will be passing from origin. See which equation I have used. It's very easy to understand. This was the equation. You can see where it is. Yeah, here it is. Ln R1 upon R2 will be equal to KT2 minus KT1. No. Wait a minute, please. Where is that equation? Okay, no problem. So you can see that you are going to take K common, so T2 minus T1. So basically this is ln R1 upon R2, and you can see this is basically Y and this is your X, directly proportional, and there is no intercept, so it will pass through poles. Is that clear? Was that clear
Yes,
to
sir.
everyone?
Sir,
Please let me know when you are done with this.
Done, sir.
Done, everyone?
yes, sir.
I'm going to give you some question. You need to solve and send it in PDF form. There will be no not much question. It's very easy. Right. Unit of rate constant. And for this is the first question. Question number 2 is the unit of rate constant. For the reaction towards 2 plus 2n will give you 2 plus N2, which has rate law expression given as K into H2 into NO whole square is. You need to write the unit. Question number 3. What will be rate equation? For the reaction 2x plus y, that will give you z. If the order of reaction is z. Option is rate equals to k into x into y. Option B is rate equals to k. Option C is rate equals to k into x raised to the power 0, y raised to the power 1. Option D, rate equals to k into x into y raised to the power 0. Please do this question 3 questions. Everyone done with this? Thank you, Madhya. I just got your answer. Solution.
So,
Yes.
so can you explain me the first one?
First one.
Is how to get the fifth order.
See, basically, are you talking about this?
Yes, sir.
First of all, there is a rate law expression. Rate will be equal to K into reactant raised to the power. Since we are talking about 10th order, just suppose, so the power will be 10 because the order of the reaction is 10. It's given. Yes or no? Last year.
Yes, sir.
Now, in order to calculate the unit of rate constant, can I write K will be equal to rate upon R raised to the power 10? Yes or no?
Yes, sir.
Do you know what is the unit of rate? It is basically change in concentration upon time. So change in concentration, that means mole per liter and time as per second. So the rate has a unit, mole per liter per second. So it is basically mole per liter per second, and this is concentration. So it will have a unit, mole per liter raised to the power 10. Again, in numerator we have mole per liter per second, and in denominator we have mole raised to the power 10 and second raised to the power minus 10. Yes or no? Is it clear up to this?
Yes, sir.
Now when this moves to numerator, it has a power 1 mole raised to the power 1 minus 10, liter raised to the power minus 1, second raised to the power minus 1, and when it will move to upward minus already and minus will come, then it will be positive. So the value will be mole raised to the power minus 9, liter raised to the power minus 1, second raised to the power 9. Is that clear?
Yes, sir.
Now if you want to calculate for nth order, just put n at the place of 10. Are you getting my point?
Yes, sir.
Then you can easily calculate.
Okay, sir. Thank you, sir.
Thank you. Everyone done with this? Please submit your PDF to Learnivio's WhatsApp number